Today we're going to be in the IMB and we're going to be working on graphing logarithmic functions. So the first thing that you want to notice is that these are inverses of each other. And I'll keep talking about that, but the domain and inverses, they're going to flip-flop. And what we want to do to be able to graph a log is they're not as friendly as the other, like an exponential. I can't just plug in if I have a log base e. I don't know really many numbers to plug in there to output input. So what we're going to do is we're going to change our log to an exponential, and then we're going to graph and get some points from the exponential, which will then enable us to find the logarithmic points. So here's our conversions. Remember, I said we could do this nice little loop method, go from the base to the output to the input. So my first log that I'm going to graph is the log with the base e, the natural log. So the first thing that we want to do is we want to find the inverse algebraically. So right now, if I'm looking at this f of x equals the natural log of x, I really don't know many values to plug in. I know if I plug in 1 for x, my output is 0 because we know that property. But really, it's not very friendly. So what I'm going to do is I'm going to rewrite this as y is equal to the natural log of x. And with inverses on equation, if I want to find the equation accurately, I'm going to then switch my x and y's because I know that's what happens on an inverse. My inputs and outputs flip-flop. And now I'm going to take the inverse, or I'm going to convert this into the inverse, which is the exponential. So I'm going to say the base, which is e, raised to the output, now the output is x, is equal to the input of the log, which is y. And I'm just going to write that y just like that. So the inverse of the natural log is the exponential e to the x. And now what I'm going to do is I'm going to plug some values into this function, which is the inverse. So this is y equals e to the x. And if I plug in -1, I get e to the -1. And if I plug in 0, I get 1. And if I plug in 1, I just get e. So this is the exponential. Now, if I want to find the log, y is equal to the natural log, I know since these are inverses, I can take the outputs of the inverse and flip them with the inputs, and now I can graph. So what I'm going to do is I'm going to graph both of these at the same time. So I know my exponential has a horizontal axis asymptote, y equals 0, -1, and then 1 over e is about a half, and then 0, 1, and then 1, 2.7, about 1/8. So right about here. And here is my graph of e to the x. Now I'm going to change my color to red, and I'm going to graph the log. The log has about, well, we said e to the -1 is about a half, and then a half, and then -1, and then 1, 0, and then 2.7, and then 1. That's what I get for my log. And this has an asymptote. Remember, the domain of the log had to be greater than 0. So here's its asymptote at x equals 0. And it's going to look like this. This is the natural log of x. And notice they both are going to reflect across the line y equals x. That's quite large. Hold on. And here's that line. Y equals x. And there is my graph of the log. So if I look at my domain and range, I'm going to call f of -x, since we said that was the inverse. I'm going to say that's e to the x. And the domain here is -infinity to infinity. and the range was 0 to infinity. And then f of x, remember, was the natural log, and its domain is from 0 to infinity, and its range is negative infinity to infinity. So let's look at one more. Let's look at a little bit more complicated one for inverse wise. Let's look at this log base 2 of x minus 1 plus 2. And what I'm going to do again is I'm going to switch my x and y's to find the inverse. But before I can find my inverse, I have to make sure my log and its input are isolated completely by itself. The only thing that I'm allowed is the words log. I'm not allowed a negative multiplier or a 2 in front of the log. Just the word log, its base, and whatever's being inputted. This time it's the y minus 1 to isolate that by itself. So I'm going to do that's pretty easy. I'm just going to subtract 2. And then once I have the log and its input isolated all by itself, I'm ready to convert now to its exponential form. So I know since these are inverses, this exponential has a base 2. It's going to be raised to the output of the log, because its input is the power, and it's going to output the input of the log, which was y minus 1. Now to get this completely by itself, I'm going to need to add this 1. Now remember, this is going to be a vertical shift up or down, so I'm not going to add it to the 2 or anything up here, so I'm going to add 1 over here, the outside, and I'm just going to tidy that up. So f of negative inverse is equal to 2 to the x minus 2, and then a plus 1. Okay. And so now what I want to do is I want to take this inverse and I want to pick plug a couple of numbers in here. Okay. And so I already have set -1, 0, and 1. So if I plug -1 into this function, I'm going to get -3. So this is 2 to the -3 plus 1. If I plug in 0, I get 2 to the -2 plus 1. And if I plug in 1, I get 2 to the -1 plus 1. So this I get about 1 over 8 plus, so this is like 1 and 1/8. And this is 1 and 1/4. And this one is going to be a half, 1 1/2. I'm just going to go ahead and graph that one. So if you notice, this one that got shifted up 1, I'm going to put my asymptote at y equals 1. And I'm going to graph -1, and I get just a smidge above the line, 0 and 1/4, so a little bit more, and then 1 and 1/2. And I know this is going to something like that. Okay, now I'm going to just flip those points, 1 and 1/8, 1 and 1/4, 1 and 1/2. Since I'm graphing, I'm just going to keep it like that. And then -1, 0, 1. I'm going to switch my color. And I know since I have a horizontal asymptote at y equals 1, I have a vertical for my log at x equals 1. And then I'm going to graph 1 and 1/8 and then -1, so down here. And then 1 and 1/4, 0. And then 1 and 1/2 and 1. The best I can, that's kind of those numbers kind of get. And I'm going to look something like this with my reflection line across y equals x. And then I'm going to look at the domain of my log, which was log base 2 of x, was that x minus 1 plus 2. And then my exponential which was 2 to the x minus 2 plus 1. And then if I look at the domain of my log, let's start over here first, it is going to be from 1 to infinity because it got shifted. And my range is still negative infinity. Whereas my exponential, its domain is 1 to infinity, and its domain, whoop, 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 got that backwards. Its domain is negative infinity to infinity, and its range is from 1 to infinity. Okay, so that's how we're going to look at graphing these, is going to its inverse, find its inverse, getting a couple easy graphing points, and flip-flopping them for the inverse. Okay, our last is kind of practicing that again. I'm going to look at two logs and see how I can transfer these back into their inverses exponential. So remember, we're going to switch x and y's to get the inverse. I'm going to isolate the log and its input all by itself. So I'm going to need to move this 2 over to the other side. Once that's done, I'm going to then turn into my exponential. So I have 2 raised to the output of the log is equal to the input of the log, which is the output of the exponential. And I'm going to subtract 1 here. And then I get f inverse is 2 to x plus 2 all minus 1. Okay, so notice this one would go, if I was describing, would be left 2 down 1. And if I was describing my x's, this would be left 1 down 2. Notice how those even flip-flop. If I'm going left 1, left would be in negative. The inverse is going in the y direction in the negative 1. And my log is going down 2, which is in the negative vertical direction. And the inverse is going in the negative x direction too. So the x and y's completely flip even on transformations. Okay. And then my next one, again, I'm going to switch my x and y's, just dealing with the natural log. I'm going to isolate that log by itself. And now I'm ready to find the exponential. This is base e raised to the output comes the input. And notice that x is up with the power where it's supposed to, and it equals the output. The output, the y matches up. And I'm going to subtract my 3, and then I'm going to write inverse. And there is my I and B. But before I get moving too forward, I wanted to go over a couple homework problems with you all, because you'll be working on this graphing packet for the next couple of days. And so I wanted to go over a couple because we hadn't really gone over these transformations really. And so what I wanted to do is notice that this is log base 2, and this one is the parent function. So you're always going to start off with the parent. And I'm going to convert this into its exponential, which is y equals 2 to the x. And what I want to do is I want to graph 3 points. But if I'm just going to graph the log function, which is fine, I'm going to need to flip-flop my exponential point. So if I'm now, my output is going to be negative 1, 0, and 1, and my input will be the flip, right? So if I plug in negative 1, I get a half. If I plug in 0, I get 1. And if I plug 1 in, I get 2. So these are the points for my log. So these are my parent function points for the log, which are the reverse or the flipped of my x and y's of the exponential. So I know I have asymptote at x equals 0, and I have a half negative 1, 1, 0, and 2, 1. And so my log, it looks like this. And now I'm just going to take those 3 points and I'm going to transform them. This would be an x-axis reflection. Next one would be right 3. And then this one would be left 2, down 1. And then I'm just going to do the reflection across the x-axis here. So that doesn't change this asymptote. It's just going to take this negative, or this 1/2 -1, and it's going to bring it up here. And same point here. And then this 2, 1 becomes 2, -1. And so it's just going to approach. So we're going to approach the asymptote. It's just going to do it like that. Okay. And so you're going to move on and do that with right 3 and push those same 3 parent function points. And on all of these, this is log base 10. So, right, you're going to work with the exponential 10 to the x. And don't forget you have stuff like this. You might want to remember that this is a horizontal stretch by 3. So you're going to multiply all your x's by 3 before you graph it of your parent function. And don't forget anytime something is inside the parentheses or that input, it's going to not be exactly the same. It's either going to switch sides. So you have those to work with. And we already graphed on our homework this parent function, so you can just pull those points over from our INB. And then the rest is working, doing these problems that we just got done. Find the inverse, state the domain and range, just like our INB on all of these. So I just wanted to go over how to do these beginning ones. I thought maybe that would be a little bit tricky. So spend the next 2 days to get this all finished up. And on Thursday, we will start our INB on properties. And then I'll see y'all next week.